Hello children, today we are going to discuss few questions from the exercise 1.3. The last class I explained about the types of functions. So today we will be doing questions based on that. Okay, so exercise number 1.3. So first of all we will deal with the question number 1 from the exercise. It is given the set A is equal to 1 to B is equal to 3, 6 and a function f is defined from A to B. It's defined like this: fx is equal to 3x. Another function g is defined from A to B, defined like this: gx is equal to x square plus 2. We have to show that f is equal to g. Means we have to prove that two functions are equal. We have to prove it. So the last class I explained about how to prove the functions are equal. There are two. It should satisfy two conditions. The number one is both the functions should have same domain, and second to both the functions, that is domain of f is equal to domain of g. Both the function domain must be same thing. And second, fx is equal to gx for all x belongs to its domain. So these are the two things we have to check it. So first of all we will see whether the functions are having same domain or not. So if you see here, f is defined from A to B, so that means the domain of f is A, that is 1, 2. And g is defined from A to B, so domain of g is A, that is also 1, 2. So naturally domain of f and domain of g is same. So here clearly we can write clearly from the question. It is given domain of f is equal to domain of g is equal to set 1, 2. So both the functions are having same domain, so the first condition is satisfied. Domain of f and domain of g equal, so that the first condition is satisfied. Now second we have to see what is the image corresponding to these elements. So first of all I will see what is the image for with respect to this is the function f of 1. I am seeing f of 1 is equal to 3 into 1, 3 into 1, that is 3. Then f of 2, 3 into 2, that is 6. So the images of with respect to the first function, the images are 3 and 6. 3 and 6 with respect to the first function, images are 3 and 6. Now for the second function, also I am trying it. What is second function? G of 1. G of 1, that is 1 square plus 2, that is 1 plus 2 is 3. And then G of 2 is 2 square, that is 4 plus 2, that is 6. So now if you observe it, both the functions images, that is f and g, both are having same images are having it corresponding to the domain. Therefore we can say that the second domain are equal. First one, second one is we can say fx is equal to gx for all x belongs to the domain of f and domain of g. Therefore we can say that f and g are equal. So f and g are equal. Two things we have to prove it. First of all, both are having same domain. And second, fx is equal to gx for all x belongs to the domain and domain of f and domain of g. See, both are having in f's images are 3 and 6. In g is also images are 3 and 6. So this is question number 1. Now let us try another question. This is from exercise number 1.3. Another question number 2, third part. Here we have to check whether the function is injectivity and surjectivity of the function. We have to check it. That means we have to check whether the function is injective. Injective means it is 1, 1. and surjective means on to. We have to check these two things for the function fx is equal to x square, and f is defined as from R to R, from real to real number to real number, defined like this: fx is equal to x square. We have to check it whether the function is injective and surjective. It is defined from f is from R to R. So from real to real, we have to check this. So we have to check it. In checking case, what you can do, we can take few number and can check it whether it satisfies or not. See, it is real numbers. So I am taking two real number. Since it is x square is there, I am taking, let it be two real number like -2 and +2. We know it belongs to these two are the real number. I have taken it from its domain. This is these two -2 and +2. I have taken those two are real numbers. We know it is taken from its domain. And now I am looking for its corresponding images. That is f of -2. I am seeing it. F of -2, if I put, it is coming -2 square, it is 4. And in f of 2, if I try f of 2, it is also 2 square is equal to 4. That means we can see that -2 and +2, they are having the same image. That is -2 and +2, both are having the same image. 4. Therefore, this is not an injective function. It is not 1-1. It is not 1-1. It is, we can say, it is many one. We can say that. It is not an injective function. F is not an injective function. Now we have to see here whether it is surjective or not. Surjective means we know that surjective means onto function, means all the elements of the what is called image group should have pre-images. So I am taking an element from the image group. That is from this real number I am taking. Okay, I am taking from the codomain part. I am taking an element. That is codomain is R. From that I am taking. Okay, I am taking -5. I am taking from R, from this part. We know -5 belongs to R, and it is from the codomain. Now, according to if it is surjective, this one should have a pre-image. Now we know that it is from the codomain. So this implies codomain and so this implies x square is equal to -5. It is from the codomain. That is why elements should be of this form. X square is equal to -5. X is equal to, we know, root -5 and plus minus we can write. But under root, negative number is not a real number. This does not belong to real number group. Okay, that means -5 is not having a pre-image. This clearly shows that -5 is not having a pre-image. So this function is not onto. That is, if I take -5 from here, this is not having any pre-image in the real numbers. -5 is not having any pre-image. Therefore, we can say that this function is not surjective. Okay, this is question number 2, third part. Now we will do question number 2. Another question we will do question number 2, fourth part. Question number 2, fourth part. Again, same type of a question. We have checked injectivity and surjectivity of the function f is defined from N to Q. We know N stands for natural number, Q stands for rational number, and the function is defined as fx is equal to x cube. This is the function. We have to check it whether it is injective or surjective. Alright, we have to check it. Here also checking means we have to try with a few number and we can verify it. So it is from natural number. So I am taking the function defined from natural number. I am taking two natural numbers. Okay, like we know natural number like 1, 2 belongs to natural number. That is its domain. It is from its domain. From the domain I have taken two elements, 1 and 2. Now I will see what is its image. What is its image? F of 1 f of 1 is 1q, that is 1. F of 2 2q, that is 8. So like that, if you take any number of elements from the natural number, its images will be all different. We will get all different images. If you take different elements from the domain, its images are also different. Therefore, we can say it is a one-one function. See here, if I go, 1 is connected with 1. Alright, now 2 is connected with 8. See, you can see one element is connected with only one element. So it is what you can say one-one function. That is, it is an injective function. It is an injective function. Now we have to see whether it is surjective or not. Surjective or not. So from this surjective, just like last question, I am taking a rational number. I am taking an element from its codomain. From the codomain, I am taking a rational codomain. I am taking an element. We know rational number. The 4 is a rational number. 4 belongs to rational number, that is from its codomain. I have taken one element 4. Now just this implies what we can say, x cube is equal to 4, x is equal to cube root of 4. We know cube root of 4 is not a natural number. It is not belongs to natural number. It is not belongs to natural number. We need a natural number. We need actually natural numbers. So that means that for the element 4 is not having any pre-image. Element 4 is not having any pre-image. This pre-image should be a natural number. It is not a natural number. So therefore we can say that this function is not surjective, because the element 4, at least one element, is not having pre-image. So it is not surjective. This is question number. This was question number 2, fourth part. Now we'll see another question. We'll see another question. Question number 4. Here we have to show that the function f is from R to R, from real to real number to real number, defined by fx is equal to 3x square minus 2. 3x square minus 2 is many one into function. We have to prove that it is many one into function. We have to prove it is many one as well as an into function. Okay? So many one, so that means we have to show that. So that we have to show that many elements are having same images. We have to show it. Many one. So I am taking from real numbers. I am taking two numbers. I am trying from real number, from the domain. I am taking two number. Okay, let it be, since because square is there, it is better to go for plus and minus number. Okay. So I am taking from the real, like minus 1 plus 1. I am taking from the domain. This belongs to, these are two real numbers and belongs to its domain. We take it from the domain, two number minus 1 and plus 1. And let's see what is its image. F of minus 1 is equal to 3 into minus 1 square. So it is 3 minus 2, it is 1. Then f of 1 I am trying it. F of 1, that is 3 into 1 square, that is 3 minus 2, it is 1. Okay, so here you can see minus 1 and plus 1. Minus 1 and plus 1 both are having same image. Both are having same image 1. So we can say that it is many one function. Therefore it is many one function. See, many elements are connected to one element. So it is a many one function. Now we have to show that it is an into function. Into function means we have to show that at least one element in the second set should not have pre-images. Or we can say that range will be a proper subset of codomain. Here codomain is real number. If you can show that the range of this function is a proper subset of codomain, then also it is an into function. So I am trying for that. Okay, into function part. So if you see this 3x square minus 2, first of all I am taking x square. We know x is a real number. X belongs to real number, that is domain all real numbers. So naturally x square is greater than or equal to 0 for all x belongs to its domain, or for all x belongs to R. We can say x square is always greater than or equal to 0. Now I will try to convert this one into this form. So this I can write 3x square. I am multiplying with 3, so greater than or equal to 0. This implies I am subtracting 2. 3x square minus 2 is greater than or equal to minus 2. This is our images, that is fx, or we can say y is greater than or equal to minus 2. That means the values of y, that is the images are from minus 2 onwards, greater than or equal to minus 2. That means we can say the range of this function, if I say range of this function, I can say that minus 2 to infinity. Minus 2 to infinity. Range of the function is minus 2 to infinity. Naturally we know that this is the subset of real number. This is a proper subset. This range of f is a proper subset of the codomain. Range is a proper, this is codomain. You can write codomain here. It's a proper subset of codomain. Proper subset of codomain. Therefore, we can say that the function is an into function. So it is into function. So first of all, we proved it is many one. First we proved many one. With help of, by taking two number, we are able to prove it very simple. Where it is many one, and then we proved it is into. Into we proved with the help of proper subset, that the range is a proper subset of codomain, so it is an into function. So this function is many one into function. This many one into function. Now another question. Another question we will do. Question number 6 we will do it. Question number 6, second part. Question number 6, second part. Here we have to state whether the function is bijective or not. Justify your answer. The function is given, f is from R to R. Is defined like this: fx is equal to 3 minus 4x. We have to state whether the function is bijective or not. Bijective means it must be 1 1 on 2, 1 1 or on 2, then only it is bijective. So we have to check it whether it is 1 1 and on 2. If it is 1 1 and on 2, then it is bijective. So first of all we will go for 1 1. It is from real to real, and here there is no square or anything like that. So we will go for the normal way of proving how to prove 1 1 function. So last class I told you that fx1 is equal, if I take two elements from here, x1 and x2, if fx1 is equal to fx2, then x1 is equal to x2. If you are able to prove, then it is 1 1. So I am taking, let x1 comma x2 belongs to R I am taking, that is from the domain I am taking, and assuming fx1, let it be, let fx1 is equal to fx2. So therefore fx1 means here I can put it 3 minus 4x1 is equal to 3 minus 4x2. I substituted fx1 and fx2. This I am simplifying, 3 cancelled, here minus 4x1 is equal to minus 4x2. So from this I am able to reach x1 is equal to x2. That is fx1 is equal to fx2 implies x1 is equal to x2. Therefore the function is 1 1. So I went for another way of proving here. Okay. So fx1 is equal to fx2 implies x1 is equal to x2 I reached. So it is 1 1 function. Now I have to prove it onto function. Onto function. Onto function means we have to prove that all the elements are having three images. So I am taking the function that is fx is equal to, so y is equal to 3 minus 4x. We know y is a real number. Okay, so from here y is a real number. From here I am making x subject. X I am making subject. So x is equal to, if I make subject 3 minus y by 4. So, and we know y is a real number. So naturally this whole thing, if you put any real number here, x is also will become a real number. If you put y any real number, if you simplify, x is also will become a real number. That means for any values of y, there is a pre-image, it's also a real number. So therefore we can say that it is an onto function. It is an onto function. That is one way of concluding. From here itself we can say that since y belongs to R implies 3 minus y by 4 belongs to R implies x belongs to R. Therefore, for all y belongs to the codomain and their corresponding images are also is from its domain. So therefore, we can say this function is onto. This is one way of proving it. This is one method of proving it. Or we can do some other way also. I will show other method also. What is the other method of proving it? Onto function. Other method. So I reached here y is equal to 3 minus 4x, x is equal to 3 minus y by 4. Now another method is like this. I will take fx. In place of x I will put this x I will put this. That is f of 3 minus y by 4. In place of x I am putting and I am simplifying it. So I just simplify. Our fx is 3 minus 4x. So now in place of this x, if you put something else, in place of this x I will put the same thing. So I am doing that. So f of 3 minus y by 4 is equal to 3 minus 4 into this x. I will replace this 3 minus y by 4. I'll simplify 3 minus 4 cancel. Minus 3 plus y, so ultimately is y. Fx is equal to y. If we can reach fx is equal to y, that means for all the elements images are coming y, so that is fx is equal to y. This way also we can prove it is an onto function. So two ways you can prove it. One method is here I have explained you. After reaching x, looking at y we can conclude it, or this is another way of proving it. Fx is substitute. Fx you do it, finally if you can reach y, then also we can see it an onto function. So this is question number 6. Now one more we will do from this exercise, question number 8. Here the set A is given as real number minus 2, that is from all real number we have to exclude 2. B is given real number, from that we have to exclude 1. Show that the function f is from A to B. This is the domain and this is the codomain. Show that f is from A to B is defined by fx is equal to x minus 1 by x minus 2 is bijective. We have to prove it is bijective. Bijective means we have to prove that 1 1 1 2 we have to do it. 1 1 1 2. It is just like the last question we can do it. 1 1 1 2. So first of all we will go for 1 1. I will take 2 elements from here like x1 x2 just like last question. So what? fx1 is equal to fx2. I am working out on this. Fx1 is equal to fx2. Just substitute and simplify. Cross multiply. Your ultimate aim is you have to reach x1 is equal to x2. Since we have to do 1 1 first. cross multiply it. x1, x2, I'm multiplying it. Just normal multiplication. Here some cancellations are possible. This cancel. 2 and 2 cancelled. Minus 2x1. I am bringing this to this side, so it will be minus x1. This I am taking a minus x2. Yes, I reach x1 is equal to x2. Therefore, we can say that the function is 1 1. Therefore, the function is 1 1. Now I will go for onto. Next part I will go for onto. So if the function is given y is equal to x minus 1 by x minus 2, we know that its codomain is r minus 1. From r we are exclude 1. Okay, so here first of all I am making x subject, cross multiplying and making x subject. X times I am grouping in one side, y minus 1, 2y minus 1, x is equal to 2y minus 1 by y minus 1. If you look at this, when y is 1, x is not defined. When y is 1, what happens? Something by 0 is not defined. So when y is 1, x is not defined. So I will avoid 1. So naturally, y cannot be 1. Therefore, the y values must belong to r minus 1. That is, all real number minus 1 will be all y values. So now if you come to the codomain, here the codomain is also, that is b r minus 1. So codomain and range are equal. Codomain is equal to range. I am getting codomain is equal to range. Therefore, we can say that the function is onto function. Now, since the function is 1 1 and onto, it is bijective. So we will stop here. Rest of the sums from the exercise work out as homework.